Hello there, this is Jeffrey. I'm just going to go over some quick Boolean operations in this video. It's going to be quite short because Boolean operations are the core of a lot of stuff we're going to get to very soon. The idea of Boolean operations is taking different values and being able to return a Boolean value based off of the values of other data types. So as a simple example, if you have two booleans x and y, with x being true and y being false, you can do some basic operations on those. You can use what's called AND logic, the first one here, or logic, or not logic. In AND logic, it will only return a value of true, so this statement only prints out true, if both of the boolean values there are true themselves. So in this case, it's going to print out false. Because that value of y is false, this entire statement, the y and x, is false. In the second case, OR logic is saying if either one of those is true or both is true, it'll say that the value of this statement is true. So in this case, since x is true, the entire statement is true. Not logic, using the exclamation point as the logical not operator, says take the opposite of whatever's there. So not true is false, not false is true. Pretty simple. The only big thing to know here, especially on the AP test, is that both of these scenarios I've shown you here use short-circuiting. Basically what it says is, when you're using AND logic, if one of them is false, the entire statement's got to be false. So since y is false here, the computer doesn't even evaluate the value of x. As soon as it hits that one value that's false, it says, okay, the entire thing's false and moves on. Because there's no need to evaluate the value of x if it knows y is false. Same thing for this case. If x is true, it doesn't need to know what y is. Since you're using OR logic, you've got a true value and some other value that's going to return true in every scenario regardless of the value of y. So the program doesn't need to check the value of y. There would be no point. It would just take extra time. So that the idea of the computer cutting off that extra calculation is called short-circuiting. It's something you'll see in every programming language, and it's very useful because it does help decrease runtime. The only other important thing to highlight in Booleans is that you can use operators such as greater than, less than, greater than equal to, less than equal to, equals, those sort of things, to take primitive types, compare them, and return a Boolean value. So in this case, the value of a equals b, this is actually a Boolean expression right here. I could say Boolean, let's call this one e equals a and b, a equals b. And what this says is if a is equal to b, then this Boolean e is going to be true. But in this case, a is not equal to b, so e is false. That's all it's saying. And the implication of this really is that you can use any sort of variables in your program, any sort of state, to create a Boolean value, and that is going to be incredibly useful in the future when you're writing if statements, while statements, and the such based off of Boolean expressions, because every sort of flow control and looping in Java has its very basis in Booleans. So understanding that you can take primitive data, or even really any data, and have a way to interpret that as a Boolean expression, in a Boolean expression as a Boolean value, very important. But for now, that's really all there is to cover. So thank you guys for watching, and hasta la vista.